Okay, can't sell stat. This is unit 3, right?
Yeah.
3.1 point, or 3.1. The z-score. Why are you still doing that to me? What is that? Do we have to put what? Oh, the little dash. Usually it just goes together. If you want to just write z and then score is 2 different words, that's fine. But typically, because it's one thing, it's called the z-score. It's not z-score, it's z-score. So the z-score is what is known as the standardized score, our standardized statistic. When you take a standardized exam, when you take a standardized exam, it's called standardized because this is what they do. They make sure that no matter when you take the SATs, it doesn't, or the MCAS or the MAP, it doesn't, every exam is not the same. So some exams are harder, right? Last year's MAP test might have been different than because they're different questions. So sometimes people score differently. And so what they need to do is they need to standardize the score so that it doesn't matter that if you took this year's SAT or last year's SAT or you took the SAT from 10 years ago, your scores should be able to be reflective across the board. An 800 or a 700 is the equivalent to a 700 back then, 700 back. Now they convert these. So first they're going to do is they're going to standardize the score. Now, this is what we often refer to as a universal measuring stick. We can compare apples to oranges. So if I told you somebody scored a 50, what would you say?
That's bad.
You would say that's bad. At MIT, there are many exams where someone scores a 50 and that's an A+. Because the average exam is like a 30.
So if it's above average, you get a higher score?
Huh?
If it's above average, you get a higher score?
Correct. Maybe you heard of things called curving. They curve the exams because the exam, the highest is a 30. Now, there might be another exam where somebody gets a 50, but then the score, they get an F because, the average was like at 70 on that exam. So just by knowing a number doesn't tell you what it is. What we need to do is we need to standardize the score. So how many standard deviations did they score above or below the average student? That's what's going to tell me the difference. 2 students might get a 50. Student A might get a 50. Student B might get a 50. The average exam score is the same, but they might have different scores. And the reason is because one might have scores that were really, really range. I've taken an exam where the average score was like a 70, but like the entire class got between a 65 and a 75. Everybody, like 90% of the students were like between a 65 and a 95. So if you got an 80, or that you got an A+ on that exam. And I've had exams where the average was a 60. Such, the Z formula, the formula that we need to be using is Z. The standardized score is equal to the value X minus the mean all over the standard deviation. Okay, so it is equal to the value minus the mean all over the standard deviation. That's the formula. That's the formula we work on or do now. It's the formula you're going to have to use many times in this class. Step 1, find a z-score. Step 1, find a z-score. You're going to keep seeing it. Right now, it's the only step. It's the only thing we're going to be doing today is finding the z-score. Today, we're going to find it and interpret it. So, what does the z-score mean? The meaning of z-score. Can anybody repeat or remember what I said the z-score is? It represents the what? I only said it once, but I want to see if anybody caught it, can already grasp it from that one part. The z-score represents, well, that's what it kind of is. It's okay. The z-score represents the number of standard deviations above or below the mean. The number of standard deviations. Because if we look at this, x minus the mu is the distance. This is the difference. This is the deviation. Remember that we call that a deviation? How far is the value from the mean? That's what the numerator talks to me about. How many points better did I score? Okay, how many inches taller am I than average? Okay? When you divide that by the standard deviations, now you're trying to say, okay, how many standard deviations is that value? So how many standard deviations are you? So if the z-score is greater than 0, what does that mean? What does that mean about the value? What does that tell you? If the z-score is greater than 0, what does that mean? Simple terms. Simple. I'm not asking. I'm going to give you a specific number. If the z-score is positive, standard deviation is always positive, regardless. That would mean that deviation is positive, which means what? X is, higher, greater than the mean.
What number is that?
Any number greater than 0. If I told you z was 0.1, if I told you your z-score was 0.1, then that means you are above average. Now, are you far above average? So, if I gave you back your exam and I said your z-score was 0.5, right now you don't know what that means entirely, okay? Because you don't know, but that at least tells you what? Z greater, that's a greater than symbol. Okay, so that means you scored above the mean. You beat the average. You're better than average. If I told you your z-score was -1, did you do well on the exam?
No.
No, because that means you scored below what? Below the mean. That means you scored. What? Z greater, so if it's above. So now Z is less than the mean, like an inch and a half shorter than the average man. I think the average male is 5'9". And I'm like 5'7.5". Squeeze it, that half. Selvin, I think you have a positive Z-score in height, yes? Selvin is above average in height. All right? If your z-score equals 0, then that means x is the same as the mean. That means you are average, you are the same as the mean. So, now, that's the first part. Something that I need you to note as well. If the absolute value of z is greater than 2. Now, what do I mean by absolute value? So, you can be, so for example, -2.2. What would the absolute value of -2.2 be? 2.2, okay? So, if the absolute value of z is greater than 2, we call this unusual. unusual
What did you roll?
outlier. Basically, outlier. So, in other words, if z is greater than 2, this is a high outlier. If z is less than 2, that means it is a less than negative 2, sorry. Low outlier. Now, some people will use the number 3, but in this course, we're just going to use 2. Basically, if you're more than 2 standard deviations above or below the mean, that's a very unusual, right?
Yes.
What are you looking for?
Can you ask to send the students a guidance after your class is over?
Yes. Both of them or just the
No,
one?
just that one.
Okay, just that one.
Yep,
Okay.
thank you.
Oh, just, I thought I was
You
going to
can
give it to him.
keep, you need this?
I was going to give it to him. Or no.
Yep.
I know which one.
Okay.
All right. So, if the z-score is greater than 3, that's really, really high. All right. So if you have a z-score of like 3, that's crazy high. So z-scores get really big really fast. So if you have a z-score of like above 2, that means you're really, really, really high. In finance, we talk about risk and we talk about standard deviations. If somebody's performing above 2 standard deviations above expected, then that's really, really high. So that's what a z-score is. So now let's go in terms of our example that we did in our do now. So in our do now, and I know some of you are going to be leaving their early college. Again, these notes will be up. Be leaving in about 3 minutes. We had Blake Lively. We had Blake who was who was 70 inches tall. Yes? Yeah. All right. And we said that the mean for women was 63.8 inches, which is like 5'3.8. So 5'4". So about 5'4" is the average height for a woman. So for you women out there, if you're higher or taller than 5'4", you are above average height. Your z-score is positive. All right. And the standard deviation for women is 2.8 inches. So let's calculate the z-score for Blake. So the z-score for Blake, I'm just going to put for Blake, would be her number 70 minus 63.8 all over 2.8. Blank is blank or standard deviation is blank standard deviations blank the mean of blank. So this is basically how the sentence will go every time when we want to interpret. So, who are we talking about? Or what are we talking? Who are we referring to? Blake. So this is the who. So Blake is, what's the z-score? 2.214 standard deviations. All right, early college. Is she above the mean or below the mean? Above the mean. Oh, sorry. Oops, I did the last part a little bit wrong. Blank of blank. It was supposed to be blank of blank. Stand to the dirt? Sorry.
You got me spelling it the same way.
Above the mean what? What was the variable? What was it?
The variable?
Of the mean height
2.8?
of?
Oh,
Who's the population?
woman.
Of women. Blake is 2.214 standard deviations above the mean height of women. We know that we use the word above because her z-score was positive. If the z-score was negative, we would use below. We would use the word below if it was negative. But we would still use the number 2.214. Do not use the number negative 2.214. The negative, we would use the word below. So, let's do Ryan. So Ryan was, what is he?
Ryan was
74 inches. The mean for men
69.3.
is 69.3. 5'9". The average male is 5'9". Average male is a little bit more than 5 inches taller than the average female. So if you are 5'5", for example, if you're a male, if you're a female, you're above average height. But if you're a male, you're below average height. But you haven't stopped growing yet. The standard deviation of men is 2.92. So let's calculate the z-score for Ryan.
Question?
What's up?
Are you taller than your wife or she's taller?
My wife is 6'4". It's 5'4", 5'4". Sorry. Kiki's looking at her face. She's like, what? My wife is 5'4". She's a shorty, so she's a runner. She's average. I might be wrong. She might be 5'3". I can't. She's 5'3" or 5'4". My driver's license when I first got my first driver's license, as you can see how my handwriting is, they thought I wrote 6'8" on my, and so when I was 5'8", and so for about 10 years my driver's license said I was 6'8". I had a very hard time getting into places once I turned 21 because they're like,
That's a lie.
"You're not. This is not you," because this driver's license says you're 6'8", and I was like, "Bro, it's typo." So the z-score for Ryan would the mean height of men. Men, not mean. So Ryan is above average height. He isn't above average. He is above. Now, is he impressively tall?
Yes.
No. He is not more than 2 standard deviations. Remember, we just said that to be impressive, to be unusually tall, you need to be more than 2 standard deviations. So he's tall, but he's not like really tall. Blake Lively is considered a supermodel height, right? They're saying that to be a supermodel, you usually need to be like 5. For a female, is to be like 5'9" or taller. Yeah. So now comes the question, final question of our notes. Who is more taller for their gender?
Blake.
The answer is Blake. Because why? No, her mean is, she's actually shorter. No, close. Her what? Her what? What do we use? What value are we using again? No. What is the value we're calculating? The whole thing around this lesson. No. We use the mean. What was it? Her z-score. Her z-score of 2.214 is greater than Ryan's z-score of 1.610. So she is more impressively tall. She's an outlier in height. She's considered a very, very tall woman. Now, she's not like ridiculously tall. Z-score, her Z-score was above 3 standard deviations, That's like really tall. That's like that's really like supermodel. That's like, whoa, for a woman. That's like playing volleyball, playing basketball. Almost every single WNBA player, female WNBA player is like 3 standard deviations. Correct. Even the point guards are at least have a positive Z-score, right? For men and women. I should add one more last thing just as an important case because I'm not here Monday. Which is more unusual? What is more unusual? Z equals negative 1.31 or Z equals 1.28? Which one is more unusual? That's the right number, but you forgot something off there. Did you say the negative? No, you had the right answer. You just forgot to say the negative. So yes, this is the answer. Because this number is more standard deviations from the mean. So this is 1.31 standard deviations below the mean. This is 1.28 standard deviations above the mean. Which one is further from the mean? This one, this Z-score. So we would consider this person more unusual than this one. Now, are either one of them unusual? Do they fall underneath the unusual range? No, remember, they have to be more than 2 to start being called unusual. And that's our lesson.